Kia ora Year 12 and Year 11. I'm going to go through two questions from the DrFrost Differentiation Full Coverage worksheet that I've set for homework. The ones that I've picked out so far are questions 13 and 14. They're both, they're quite similar questions, and both people who've done it so far have got them wrong, but they've got about halfway there. So what we've got here is we're given x in terms of y, but our goal is to find dy by dx. So we can do this as follows. We can differentiate and get dx by dy, and then we can figure out dy by dx, because we know that dy by dx will be the reciprocal of dx by dy. The trouble is, we're asked to find dy by dx as a function of x, not as a function of y. And this is where the two students so far have come a little bit unstuck. And the key to this question and the next one is to use Pythagoras to work it all out. So let's start off by having a look at what we've got. Well, we've got x is equal to the log of sec 2y. So we can find dx by dy by using the chain rule. So we've got the natural log of this thing here. So the first part of the derivative will be 1 over sec 2y. Now we have to differentiate this with respect to y. So that will give me sec 2y tan 2y times 2, right? Because I've got a chain rule and then a chain rule inside it. Simplifying, I get 2 tan 2y. So that's all very good. We've got dx by dy, and it's equal to 2 tan 2y. That means that dy by dx is going to equal 1 divided by that, 1 over 2 tan of 2y. But we have to get rid of the y. We have to have something in terms of x. So the way to do this is to go all the way back to what we started with. How are x and y related? Well, we've got x is equal to the log of sec 2y. To undo the log, we can do this. E to the power of x is equal to sec of 2y. Now let's think about when that's true. No, I think that's fine, okay? We have to make sure, of course, that sec of 2y is strictly positive, because we can't take, for the log of x, we must have x greater than 0, right? But we're not going to worry too much about all of those restrictions here, because they flow through okay. So I'm being a little bit loose. But there's e to the x is equal to sec of 2y. But we don't want sec of 2y, we want tan of 2y. As soon as I see something like this, I'm going to use Pythagoras, and I'm going to draw my little Pythagoras picture. So the angle in here is 2y. Sec of 2y is equal to e to the power of x over 1, which is equal to the hypotenuse over the adjacent, right? Because sec is the reciprocal of cos, so katoa. That means that I can write my triangle out like this. The hypotenuse is e to the power of x, and the adjacent side is 1. So to figure out tan of 2y, I need to have, so katoa, this side here and this side here. So applying Pythagoras, we get this. 1 squared plus, let's call this o, 1 squared plus o squared is equal to e to the x squared. So the opposite side squared is equal to e to the 2x minus 1, which gives me the opposite side is equal to e to the power of 2x minus 1 square rooted. So we're just about there. That means that I can write that side on. So let's do that now. We've got e to the 2x minus 1, and we need to figure out tan of 2y. So we've got dy by dx is equal to 1 over 2 tan 2y, which will equal 1 over 2 root e to the 2x minus 1. Okay, so that's the first one of those done. And the second one is very similar. It's probably slightly easier. And here it goes. So question 14 gives us this. X is equal to 2 sine of y over 3. And again, we have to find dy by dx in terms of x. So first we differentiate x with respect to y. And that will give me 2 cos of y on 3 times 1/3. So dx by dy is equal to 2 cos y on 3 over 3. dy by dx will be the reciprocal of that, which is 3 over 2 cos y on 3. And we're faced with the same issue we had before. We need to get our answer in terms of x, not y. So let's look at what we started with. Well, we had x is equal to 2 sine of y on 3. Or x over 2 is equal to sine of y on 3. So we can think of x and 2 as the opposite in the hypotenuse. And the angle is going to be y on 3. So drawing up our Pythagoras situation, this is what we've got. So our missing side will be 4 minus x squared, all square rooted. So cos of y on 3 is going to equal the adjacent over the hypotenuse, right? So this one is my adjacent and this one's my hypotenuse. So we can take this and we can substitute it back in here. And that gives me dy by dx is equal to 3 over 2 times cos of y on 3, giving me a final answer of 3 over the square root of 4 minus x squared. So there you go. Make sure you go through those thoroughly and don't get confused with implicit, because we're not doing any implicit differentiation here. The only thing that we're doing that is kind of weird is that usually we have y as a function of x, but here we're starting with x as a function of y. So we're finding dx by dy, then we're taking the reciprocal, but then we've got trouble because we've got y in our answer, and we need to have our answer in terms of x, so we have to do a little bit of work to rearrange. And in both of these two questions, we've done that using some creative Pythagoras theorem. Thanks for watching, and if there are any more of the Dr. Frost questions that you're really stuck on, just send me an email and let me know, and I'll whip up a YouTube for you.